Now look at another example given on same page, that is page number 55. Here if you look at the first box, how many balls are there? 3 balls are there. So we will write here it as 3 balls. Now how many triangles are there? 3. So we write it as 3 triangles. Now in place of object, here the alphabet is taken. So how many T's are there? 3. So we write here it as 3 T's. Now what is this 3T? It is an algebraic expression. Now whenever we write using any alphabet, which is here it is taken as T. So here 3T is an algebraic expression. Now in this example, here 2 balls and 3 bats are there. So we write it as 2 balls plus 3 bats. Now how many mangoes are there? 2 mangoes. And how many guavas are there? 3. So we write here as 2 mangoes plus 3 guavas. So we take in place of the objects, here alphabets are taken. As the numbers of objects is same. In place of 2 balls or 2 mangoes, here 2x are taken. So here when we add x plus x, we get 2x. Now here in first example, 3 bats are there. In second example, 3 guavas are there. In this example, 3 times y is added. So when you add y 3 times, you will write it as 3y. So when you write any number alphabet like this, you will get an algebraic expression. So here 2x plus 3y is an algebraic expression. Now here you know the perimeter of a rectangle. What is perimeter? Sum of length of all the sides. In rectangle we know opposite sides are same. So here if you consider length as small l and breadth as small b, so you will get the perimeter of rectangle as 2 times length plus 2 times breadth. But if you take 2 common, you will get the expression as 2 bracket length plus breadth. Now in all these examples, 3n plus 1, 3t, 2x plus 3y, 2 into length plus breadth, these all are algebraic expressions. Now in all these algebraic expressions, here the alphabets that are used are all variables. Just as in first expression, n is the variable. In second expression, t is the variable. In third expression, x and y are the variables, whereas in this expression, l and b are the variables. Why we are telling them as variables? Because their values are changing. Now, if you look at this expression, 3x. In this expression, 3 is the coefficient of the variable x. Now here we know that whatever alphabet we are using, we are telling it as a variable. So the number that is written along with the variable is called as an coefficient. So in this expression 3x, here 3 is the coefficient and x is the variable. Now if you look at the another expression, negative 15t. Now again in this expression, t is an alphabet. So wherever we are writing any alphabet, we call it as the variable, and here the coefficient is negative 15. So in the expression negative 15t, negative 15 is the coefficient of the variable t. Now what is a term? An expression in which multiplication is the only operation is called as term. Now here if you look at this expression 3x, here there is multiplication between 3 and x. That is only multiplication is the only operation in this expression. So this is one term. Similarly, if you look at this expression negative 15t, there is multiplication between negative 15 and t. So here this is again only one term, that is negative 15t. So whenever there is in any expression, if multiplication is the only operation in the given expression, then it is called as a term. Now in an algebraic expression may have one term or may be the sum of several terms. In the previous expressions, we have seen that some expressions have only one term, whereas some expressions have more than one term. Now, if you look at this example, in the algebraic expression, 4x square minus 2y plus 5 upon 6xz. Now, here there are three terms. 4x square is the first term, second term is negative 2y, the third term is 5 upon 6xz. Because in 4x square, multiplication is the only operation. In negative 2y, again multiplication is the only operation. And in the third term, 5 upon 6xz, only multiplication is the only operation. But these signs or these symbols, negative, plus and minus, they separate the terms. That is, 4x square is the first term, negative 2y is the second term, and 5 upon 6xz is the third term. Now, if you look at the first term, 4x square, what is the coefficient? Here 4 is the coefficient. In the second term, negative 2y, what is the coefficient? Negative 2 is the coefficient. Whereas in the third term, 5 upon 6 is the coefficient in it. Now, if you look at the table here, in the first column, term is given. In the second column, coefficient is written. And in the third column, variables are written. Now, the first term is 11mn. Here the coefficient is 11, whereas the variables are m and n. Now, in second example, the numerical part represent the coefficient and the alphabetical part represent the variables. So, here negative 9 is the coefficient, whereas variables are x and y. Now, again, here the numerical part is 5 upon 6. So, 5 upon 6p, 5 upon 6 is the coefficient and p is the variable. But if you look at the last example, a, here the coefficient is not given. But we know that when any number is multiplied by 1, we get the same number as the product or the number itself as the product. So, here if there is no coefficient, we consider 1 as the coefficient of that number. Now, so the coefficient of a is 1 and a is the variable. Now, if you look here in this expression, the algebraic expression 15 minus x has two terms. Which two terms are there? 15 is the first term and the second term is negative x. Now, the first term is a number. The first term don't have any variable. So, it is not necessary that every term should have the variable. So, here it is also called as a constant term. When there is no variable attached with the given number, then it is called as constant. So, here the first term 15 is a number, whereas second term is negative x. Here the coefficient of the variable x is negative 1. Here it is minus x. Minus x, it is minus 1 multiplied by x. Hence, we tell the coefficient of x as minus 1. Now, terms which have same variables with the same powers are called as like terms. Now, here we will see different types of terms, like terms and unlike terms. Now, what are like terms? If the terms have same variable. Also, if the power or the index of the given variables is same, then they are called as like terms. So, let us take some example of like terms and some examples of unlike terms. If you look here at like terms, here in the first example, 2x, 5x, negative 2 upon 3x. In all these three terms, the variable part is same. Whenever we see like terms, we will see only the variable part. In the first term, the variable is x. In second term, variable is again x. In third term, the variable is x. Hence, all these three terms are like terms. Now, if you look at the second example, minus 5 x square y and 6 upon 7 y x square. Now, again look at the variable part. Here x square, yes, there is x square in this term also, and y multiplied by y. Hence, x square y and y x square are like terms. Why we are telling x square y and y x square are like terms? Because we know that whenever you multiply 2 with 3 or 3 with 2, the answer is same. Similarly, x square multiplied by y or y multiplied by x square, the answer is same or the product remains the same. Hence, x square y and y x squares are like terms. If you look at the index of x here is 2. Also, here the index of x is 2. Here the index of y is 1. Whenever the index is not given, we consider it as 1. Hence, the index of y is same in both the terms. Hence, my negative 5x square y and 6 upon 7 y x square are like terms. Now, if we look at unlike terms, let us see some examples. 7xy, 9y square, negative 2xyz. In all these three terms, if you look at the variable part, here the variables are x and y. Here it is y square. Here it is xyz. Here the variables are different. Hence, these three are unlike terms. Now, if you look at the second example, 8mn, 8m square n square, 8m cube n. Now, in this second example, even the variables are same, that is m and n, but their indices are different. Here the index of m is 1, here it is 2, here it is 3. Hence, we will say that these three terms are unlike terms, because according to a condition, if the terms have same variables with the same powers, then only they are like terms. Otherwise, when they have same variables or different parts, then they are unlike terms. Even if they have different variables or different parts, then the terms are unlike terms.